Welcome to this peaceful journey along the tranquil waterways of the Amazon basin. As you settle in and find a comfortable position, allow your mind to drift with me to the gentle flowing rivers of South America. The Amazon basin encompasses a vast expanse of land, spreading across 8 countries in a peaceful coexistence with nature. Brazil, Peru, Colombia, Venezuela, Ecuador, Bolivia, Guyana, and Suriname all share in the nurturing embrace of this remarkable geographical feature. As you breathe slowly and deeply, imagine the soft, humid air of the basin filling your lungs. The Amazon basin covers approximately 2.7 million square miles, a number so vast it becomes almost abstract in its peacefulness. This immense area represents about 40% of the South American continent, a gentle reminder of how natural features transcend human boundaries and connect distant places through flowing water. The basin is defined by its rivers, with the mighty Amazon at its heart. Moving at a consistently gentle pace of about 1.5 miles per hour, the Amazon River flows unhurriedly across the continent, never rushing, always steady in its ancient journey. This consistent, reliable movement has continued for millions of years, a soothing reminder of nature's patient persistence. As we begin our journey, allow yourself to picture the soft morning mist rising from the surface of the water. The moisture in the air creates a gentle blanket above the river, diffusing the early light into a soft glow that lacks any harshness or sudden contrast. This calm beginning to the day happens with reliable regularity throughout the basin, creating a natural rhythm that has continued uninterrupted for countless generations. The main stem of the Amazon River measures approximately 4,000 miles in length, or perhaps 4,100 miles, depending on which measurement study one considers. This mild uncertainty in the exact measurement is itself a soothing reminder that even in our modern world of precise instruments, some natural features maintain a gentle mystery about them. The river begins as a small stream in the Peruvian Andes, at the Nevado Mismai Peak, at an elevation of approximately 16,000 feet above sea level. From this modest beginning, the river begins its unhurried journey eastward. It flows with a consistent, dependable rhythm through Peru, entering Colombia briefly before crossing into Brazil, where it continues its measured progression toward the Atlantic Ocean. Throughout this extensive journey, the river maintains a peaceful demeanor, never expressing the violent rapids or dramatic falls that characterize many other major rivers of the world. The Amazon basin receives between 80 and 120 inches of rainfall annually, distributed with relative evenness throughout the year. This gentle precipitation supports the basin's lush vegetation and contributes to the steady, reliable flow of the river system. The rainfall creates a soothing background rhythm to life in the basin, a soft patter against the vast canopy of leaves that stretches across much of the region. As your breathing continues to find its natural, comfortable rhythm, consider how the Amazon basin has been shaped over millions of years through gradual, almost imperceptible processes. The Andean mountains rose slowly over tens of millions of years, their elevation increasing by mere millimeters annually. This unhurried geological process redirected rivers and created the basis for the basin we observe today. The soil throughout much of the basin consists of reddish or yellowish oxasols and ultisols, names that might sound technical but simply refer to soils that have developed over very long periods in warm, moist environments. These soils have been forming gradually for thousands of years, each season adding the tiniest layer of new material in a process so slow it defies human perception. As we continue our gentle exploration, let us consider the peaceful beginnings of the tributaries that feed the main Amazon River. Each one starts as a modest stream, often emerging from underground springs where water has percolated slowly through layers of rock, filtering and cooling as it makes its unhurried way to the surface. These springs maintain a nearly constant temperature throughout the year, typically between 50 and 55 degrees Fahrenheit, creating small pools of remarkable consistency in an ever-changing world. Now, as we move deeper into our journey, let us explore the gentle tributaries that feed the main Amazon River. The basin contains over 1,100 tributaries, a number that loses meaning in its magnitude and becomes merely a soothing reminder of abundance. Of these numerous waterways, 17 exceed 1,000 miles in length, each one a significant river in its own right, yet all ultimately contributing to the greater flow of the Amazon. The Negro River joins the Amazon near Manaus, creating a remarkable natural phenomenon known as the meeting of the waters. Here, the darker water of the Negro flows alongside the lighter, sediment-rich water of the Amazon for approximately 6 kilometers before fully mixing. The two rivers move at slightly different speeds, the Negro at approximately 2 kilometers per hour, and the Amazon at approximately 4 kilometers per hour. This difference in velocity contributes to the prolonged parallel flow before the waters eventually blend together. The Madeira River, another significant tributary, extends approximately 2,020 miles from its furthest source. Its name, which means wood in Portuguese, refers to the substantial amount of driftwood often observed floating along its surface. The river's width varies between 1 and 3 miles, depending on the season and location, creating a gentle variation that never becomes extreme or dramatic. As your body continues to relax and your breathing maintains its comfortable rhythm, consider the Tapajos River, which joins the Amazon near the city of Santarém. The Tapajos flows approximately 1,200 miles from its source and maintains an average width of about 2 miles throughout much of its journey. Its waters contain fewer suspended sediments than the main Amazon, giving it a clearer appearance that allows visibility to depths of approximately 2 to 3 meters in some locations. The Singu River presents another peaceful tributary, winding approximately 1,230 miles through the Brazilian landscape before joining the Amazon. Along its journey, the Singu passes through several minor rapids, none exceeding a modest drop of 3 to 4 feet, creating gentle disturbances in the otherwise smooth flow of water. The river's width varies between 1.5 and 2.5 miles for much of its lower course, providing ample space for the water to move unhurriedly toward its destination. The topography of the Amazon basin demonstrates remarkable consistency throughout much of its expanse. The elevation change across thousands of miles remains minimal, with the river dropping only about 345 feet in elevation over the 2,000 miles from Iquitos, Peru, to the Atlantic Ocean. This translates to a barely perceptible gradient of approximately 0.03 feet per mile, or just 2 inches of elevation change per mile of river flow. This gentle gradient contributes to the river's consistently slow pace, allowing it to meander across the landscape with seemingly infinite patience. The unhurried flow creates numerous oxbow lakes throughout the basin, formed when the river's soft curves become increasingly pronounced over time, until eventually the river finds a more direct path, leaving behind a crescent-shaped body of still water. These oxbow lakes typically measure between 0.5 and 3 miles in length, with widths rarely exceeding 0.5 miles. They gradually transform over decades, slowly filling with sediment and aquatic vegetation. Some oxbow lakes in the Amazon basin have been dated to approximately 500 years of age, while others are considerably younger, perhaps only 50 to 100 years old, indicating the ongoing, unhurried nature of this geographical process. The floodplain of the Amazon, known regionally as the Várzea, extends outward from the main channel for distances ranging from 5 to 50 miles, depending on the local topography. This vast, flat area experiences annual flooding, with water levels rising between 20 and 40 feet during the wet season. The flooding occurs with such consistency and gradual pace that it creates minimal disturbance, rising at rates typically not exceeding 3 to 4 inches per day. Throughout the basin, one finds countless islands, numbering perhaps in the thousands, although no complete inventory has ever been conducted. These islands range in size from small, temporary sandbanks of perhaps an acre or less to substantial land masses extending 30 or more miles in length. Marajo Island, located at the mouth of the Amazon, encompasses approximately 15,500 square miles, making it larger than the nation of Switzerland or the state of Maryland. The soil composition across these islands demonstrates subtle variations in mineral content and organic material. Some islands contain soils with silicon dioxide concentrations of approximately 45 to 60%, while others present higher levels of aluminum oxide, typically in the range of 15 to 25%. These minor variations create barely perceptible differences in the vegetation supported by each island, contributing to the basin's biodiversity through the gentlest of influences. As we continue our peaceful journey, consider the river's depth, which averages between 20 and 50 meters throughout much of its course. In some locations, particularly near the confluence of major tributaries, depths may reach 100 meters or more. The greatest recorded depth, approximately 100 meters, occurs near Abidos, Brazil, roughly 600 miles inland from the Atlantic Ocean. As we move into the middle portion of our journey, let us consider some of the mild statistical information that helps us understand the geographical relationships within the Amazon basin. The Amazon River discharges approximately 209,000 cubic meters of water into the Atlantic Ocean every second. This number, while impressive in magnitude, represents a consistent, dependable flow that varies only moderately with the seasons. During the annual high water period, this discharge may increase to approximately 235,000 cubic meters per second, while during the low water period, it may decrease to approximately 175,000 cubic meters per second. This variation, occurring over the course of months rather than hours or days, creates a gentle rhythm that defines life throughout the basin. The Amazon carries approximately 1.2 billion tons of sediment to the Atlantic Ocean annually. These sediments consist primarily of silt and clay particles, with diameters typically ranging from 0.002 to 0.05 millimeters. The majority of these sediments originate in the Andean regions of Peru, Ecuador, and Bolivia, where geological processes continue their unhurried work of wearing down the mountains, particle by particle. The water temperature of the Amazon and its tributaries remains remarkably consistent throughout the year. The main stem of the Amazon typically maintains temperatures between 28 and 30 degrees Celsius, 82 to 86 degrees Fahrenheit, with diurnal variations rarely exceeding 1 degree Celsius. This thermal stability creates an environment of predictable comfort for the numerous aquatic species that inhabit these waters. The basin contains approximately 1,500 fish species that have been scientifically described, although estimates suggest the actual number may be closer to 3,000 species. Each of these species occupies a particular ecological niche, defined by factors such as water depth, current speed, and proximity to the shoreline. The peaceful coexistence of these numerous species demonstrates the remarkable capacity of natural systems to find balance through specialization. The basin's fish population includes approximately 85 species of electric fish, primarily from the families Gymnotidae and Apteronatidae. These fish generate weak electrical fields, typically between 10 and 100 millivolts, which they use for navigation and communication in the often murky waters. The electrical signals pulse at consistent frequencies, typically between 50 and 500 hertz, creating an inaudible rhythm beneath the water's surface. Dissolved oxygen levels in the Amazon River typically range between 4 and 8 milligrams per liter, with slight variations depending on temperature, current, and proximity to tributary inflows. These levels remain sufficient to support the diverse aquatic life throughout most of the river system, creating an environment of moderate abundance rather than either scarcity or overwhelming plenty. The pH of the Amazon River averages between 6.2 and 7, indicating a slightly acidic to neutral chemical composition. Some tributaries, particularly those draining regions with high concentrations of decaying organic matter, may present pH values as low as 4.5, while others may approach 7.5, creating a gentle spectrum of acidity across the basin. The Amazon basin encompasses approximately 2.1 million square miles of forest cover, representing the largest contiguous tract of rainforest on our planet. Within this forest, scientists have documented approximately 16,000 tree species, although the actual number likely exceeds 20,000. Each species occupies a particular ecological niche, defined by factors such as soil type, rainfall patterns, and elevation. The average tree density in the Amazon rainforest is approximately 200 to 300 trees per hectare, 2.47 acres, creating a moderately dense but not overcrowded canopy. These trees typically reach heights of 30 to 45 meters, 100 to 150 feet, with the tallest specimens occasionally exceeding 55 meters, 180 feet. The canopy they form intercepts approximately 80 to 90% of the rainfall, creating a softer, gentler precipitation experience at the forest floor. The rate of water flow in the Amazon varies with location and season. Near Iquitos, Peru, the average flow speed is approximately 1.5 meters per second, while near Manaus, Brazil, the speed decreases to approximately 0.8 meters per second. During flood periods, these speeds may decrease slightly due to the backwater effect created by the increased volume of water downstream. The width of the Amazon River also demonstrates gentle variation throughout its course. Near Iquitos, Peru, the river spans approximately 2.5 kilometers, 1.5 miles, during normal flow conditions. Near Manaus, Brazil, the width increases to approximately 4 kilometers, 2.5 miles. During the annual flood season, the width near Manaus may expand to approximately 10 kilometers, 6.2 miles. As the river spreads across its floodplain with unhurried deliberation, the Amazon basin receives rainfall totaling between 2,000 and 3,000 millimeters, 80 to 120 inches, annually, depending on the specific location. This precipitation occurs on approximately 200 to 220 days per year, creating a generally consistent pattern of gentle moisture. The rainfall intensity typically averages between 5 and 15 millimeters per hour, rarely presenting the violent downpours characteristic of some tropical regions. The groundwater reserves beneath the Amazon basin have been estimated at approximately 70,000 cubic kilometers, a volume so vast it becomes merely an abstract number, soothing in its immensity. This water moves through the subsurface at rates typically between 1 and 10 meters per year, a pace so gradual it defies human perception and reminds us of nature's unhurried processes. As we continue our gentle journey through the Amazon basin, let us consider the climate patterns and seasonal variations that characterize this region. The basin experiences a tropical climate classified primarily as AF under the Köppen climate classification system, indicating a consistently warm temperature and abundant rainfall throughout the year. The average annual temperature across the basin varies between 24 and 27 degrees Celsius, 75 to 80 degrees Fahrenheit, with minimal seasonal variation. The difference between the warmest and coolest months typically amounts to merely 1 to 2 degrees Celsius, creating an environment of remarkable thermal consistency throughout the year. Daily temperature variations prove somewhat more pronounced, with diurnal ranges typically between 8 and 12 degrees Celsius, 14 to 22 degrees Fahrenheit. Temperatures generally reach their lowest point between 4:00 and 6:00 in the morning, gradual rising to peak between 13:00 and 15:00 in the afternoon, before beginning their unhurried decline through the evening hours. Relative humidity throughout the basin typically ranges between 80 and 90%, creating a consistently moist atmosphere. The humidity level generally reaches its highest point in the early morning hours, typically around 5:00, when temperatures are at their lowest. The humidity decreases slightly during the afternoon as temperatures rise, before gradually increasing again through the evening hours. The basin experiences rainfall patterns that vary both geographically and seasonally, though these variations occur within a consistently moist environment. The northwestern portion of the basin, encompassing parts of Colombia, Ecuador, and Peru, receives rainfall distributed almost evenly throughout the year, with monthly totals typically ranging between 200 and 300 millimeters, 8 to 12 inches. The central and eastern portions of the basin demonstrate somewhat more pronounced seasonality. In these regions, the period from December through May generally receives higher rainfall, with monthly totals often exceeding 300 millimeters, 12 inches. The period from June through November experiences slightly reduced precipitation, with monthly totals typically between 100 and 200 millimeters, 4 to 8 inches. This mild seasonal variation creates gentle fluctuations in river levels throughout the basin. The Amazon River at Manaus, Brazil, typically reaches its highest level in June, approximately 3 months after the peak of the rainy season in the upper basin. At this location, the river level may rise approximately 10 to 12 meters, 33 to 39 feet above its lowest point, which typically occurs in November. This predictable, gradual rising and falling of water levels has shaped life throughout the basin for countless generations. The flood pulse creates temporary aquatic habitats that may persist for 4 to 8 months, depending on local topography and the magnitude of the annual flood. These habitats extend across approximately 300,000 square kilometers, 115,800 square miles, during an average flood year. The Amazon basin experiences minimal seasonal variation in daylight hours due to its equatorial location. Near the city of Manaus, located almost directly on the equator, daylight duration varies by only about 16 minutes throughout the year, from approximately 11 hours and 52 minutes to 12 hours and 8 minutes. This consistency in day length contributes to the stable growing conditions throughout the basin. Cloud cover across the Amazon basin typically ranges between 60 and 80%, with slight seasonal variations. During the wetter months, cloud cover may increase to approximately 85%, while during the drier period, it may decrease to approximately 55%. The clouds most commonly take the form of cumulus and stratocumulus formations, creating a soft, textured canopy overhead. The prevailing winds in the Amazon basin blow predominantly from the east, driven by the trade wind system. These winds typically maintain velocities between 5 and 15 kilometers per hour, 3 to 9 miles per hour, creating a gentle but persistent movement of air across the landscape. The wind direction demonstrates remarkable consistency, varying by no more than 20 to 30 degrees from true east throughout much of the year. Occasionally, cold air masses from the southern regions of South America may penetrate into the southern portions of the Amazon basin, creating what locals refer to as friagem events. During these periodic occurrences, temperatures may decrease by 5 to 10 degrees Celsius, 9 to 18 degrees Fahrenheit, for a period typically lasting between 3 and 5 days. These events occur with greatest frequency during the June to August period, typically happening 2 to 4 times annually. The Amazon basin receives solar radiation averaging approximately 1,800 to 2,200 kilowatt hours per square meter annually. This energy input demonstrates mild seasonal variation, with the highest values typically occurring during the August to October period, when cloud cover reaches its annual minimum. The lowest values generally occur during the December to February period, coinciding with increased cloud cover. Evapotranspiration rates throughout the basin typically range between 1,000 and 1,500 millimeters, 39 to 59 inches, annually. This process returns approximately 50 to 60% of the precipitation back to the atmosphere, creating a partially closed hydrological cycle that contributes to the basin's consistent rainfall patterns. The daily evapotranspiration rate averages between 3 and 5 millimeters, with slight variations based on temperature wind speed, and cloud cover. The air pressure across the Amazon basin averages approximately 1010 to 1014 millibars at river level, with minimal diurnal or seasonal variation. This consistency contributes to the stable weather patterns observed throughout much of the basin, lacking the dramatic frontal systems characteristic of higher latitudes. As we approach the final portion of our journey through the Amazon basin, let us turn our attention to the most mundane aspects of human geography in this region. The basin encompasses areas within 8 countries, with approximately 60% of its area falling within Brazilian borders. The human population throughout the basin numbers approximately 30 million individuals, representing an average population density of approximately 11 persons per square kilometer. This population distribution demonstrates considerable unevenness, with density decreasing with distance from major waterways. In areas adjacent to the main rivers, population densities may reach 15 to 20 persons per square kilometer, while in interfluvial regions, areas between rivers, densities often fall below 5 persons per square kilometer. The basin contains approximately 72 urban centers, with populations exceeding 50,000 inhabitants. These centers are predominantly located along major waterways, reflecting the historical importance of rivers for transportation and commerce. The largest city within the basin, Manaus, Brazil, has a population of approximately 2.2 million inhabitants and is situated at the confluence of the Negro and Amazon rivers. Traditional settlement patterns throughout much of the basin have followed a riverside orientation, with dwellings typically constructed 30 to 100 meters from the water's edge. This placement represents a careful balance between accessibility to the river and protection from annual flooding. Structures in these settlements are often elevated on stilts, raising the living space 2 to 3 meters above the ground to accommodate seasonal fluctuations in water level. The transportation network throughout the basin relies heavily on waterways, with approximately 25,000 kilometers, 15,500 miles, of navigable rivers. River travel times reflect the unhurried pace of life in the region. A journey from Manaus to Belém, covering approximately 1,300 kilometers, 800 miles, typically requires 5 to 7 days aboard a regional boat service. Land transportation infrastructure remains limited, with road density averaging approximately 0.05 kilometers of road per square kilometer of land area. This figure stands in contrast to more densely developed regions of Brazil, where road density may reach 0.5 kilometers per square kilometer. The limited road network contributes to the continued importance of river transportation throughout the basin. Agricultural activities within the basin include both traditional subsistence practices and larger commercial operations. Subsistence agriculture typically occurs on plots of 1 to 3 hectares, 2.5 to 7.5 acres, and often employs shifting cultivation techniques. These small plots typically produce yields of approximately 1 to 2 tons of manioc per hectare, or 0.5 to 1 ton of maize per hectare. Figures that reflect the moderate fertility of many basin soils. Commercial agriculture has expanded in recent decades, particularly in the southern portions of the basin. Soybean cultivation now occupies approximately 30 million hectares, 74 million acres within the broader Amazon region, with average yields of approximately 3 tons per hectare. This expansion has occurred at an average rate of approximately 3 to 5% annually over the past 2 decades. Traditional fishing activities support approximately 200,000 households throughout the basin. Annual fish harvests from wild capture amount to approximately 200,000 tons, representing an average catch of approximately 1 ton per fishing household. This moderate productivity reflects the sustainable nature of many traditional fishing practices. The extractive industries within the basin include rubber tapping, Brazil nut collection, and acai harvest, among others. These activities typically yield products with low weight-to-value ratios, making them economically viable despite the transportation limitations. A typical rubber tapper may collect approximately 400 to 600 kilograms of latex annually, while a Brazil nut collector may gather 1,000 to 1,500 kilograms of nuts during the harvest season. The linguistic landscape of the basin demonstrates considerable diversity, with approximately 350 indigenous languages still spoken to some degree. Many of these languages have speaker populations numbering fewer than 1,000 individuals, and approximately 25% of these languages are considered at risk of extinction within the next generation due to declining speaker populations. The basin's population presents a demographic profile with a median age of approximately 24 years, reflecting a relatively youthful population structure. Birth rates average approximately 22 births per 1,000 population annually, while mortality rates average approximately 5.5 deaths per 1,000 population. These figures translate to a natural population increase of approximately 1.65% annually, excluding migration effects. Access to education demonstrates geographic disparities throughout the basin. In urban centers, primary school enrollment rates typically exceed 90%, while in remote rural areas, these rates may fall to 70% or lower. Secondary school enrollment demonstrates a more pronounced disparity, with rates of approximately 70% in urban areas declining to 30% or lower in remote regions. As our journey through the Amazon basin approaches its conclusion, let us reflect on the gentle, flowing nature of this remarkable geographical feature. The waterways we have explored move with unhurried consistency across the landscape, neither rushing nor stagnating, but simply continuing their ancient journey day by day and year by year. The human communities along these waterways have adapted to the rhythms of the basin, developing lifestyles that accommodate the seasonal rising and falling of the rivers. Their activities follow patterns established over generations, reflecting an accumulated understanding of the environment's gentle cycles. As you continue to rest comfortably, allow your thoughts to flow like the rivers we have described, moving without urgency from one moment to the next. The Amazon basin exists in a state of unhurried continuity, its waters flowing today much as they have for countless years past, and as they will continue to flow for innumerable years to come. The statistical details we have explored, the river depths, the rainfall patterns, the population figures, all fade into a soothing background of information, present but not demanding your attention. Like the gentle sound of rainfall on dense foliage, they create a consistent, predictable pattern that allows your mind to gradually disengage. As we conclude our journey, picture once more the broad, peaceful surface of the Amazon River, reflecting the soft light of early morning or late afternoon. The water moves steadily, reliably, without dramatic disturbance, continuing its timeless journey toward the distant Atlantic. And like the river, you too can continue your journey toward restfulness, moving steadily and naturally toward the deep peace that awaits.